And I'm back. Now the reason I'm back is because I recently saw something on YouTube and I wanted to weigh in. So there's this kid named Michael Reeves who recently posted a video of himself building an ejector chair. Now for those of you who don't know who Michael Reeves is, he's basically the human version of Kevin the Minion. Only with more hair and a shit ton of acne. I mean, really, his acne is no joke. It's as if his face caught on fire and somebody tried to put it out with a fucking ice pick. But that's aside from the point. Anyway, he posted this video of himself building this ejector chair, and I had to weigh in because of how he used his pneumatics. Now don't get me wrong, Michael, you are a smart kid. You know what you're doing when it comes to programming and electronics. But when it comes to pneumatics, dude, you've got a long way to go. Having an air compressor and knowing how to turn on and off a solenoid valve just does not cut the mustard. Not on my watch, and I fucking love my mustard. So what I'm going to do is rebuild that ejector chair, but this time using all pneumatics and making it so it's not as complicated as he showed in his video. So the first thing I'm going to need is a chair. The second thing I'm going to need are some pneumatic components, which I've got. Finally, I'm going to need the appropriate fittings and connectors so I can actually get this done. That being said, let's fucking continue, shall we? So I'm going to start things off with a 3-2 valve. Air's gonna go in here, and this is going to be the switch for the air cylinders. This end is going to actuate the pilot valve, which I've got here. Ah, fuck. So here's the pilot valve, and this, much like my switch in the pneumatic useless machine, this is a 5-2 valve, but this time, instead of there being a switch to actuate the air, there is an air signal, which is going to come from this valve. Now, Michael was actually using something very similar to this. In fact, it was also a 5-2 valve. But instead of it being an air-piloted valve, it was a solenoid valve, which means there's an electromagnet on top of here, and once it receives an electrical signal, it moves up a plunger, and that's what actuates the air. But the fact of the matter is, you don't need all these electronics and codes and programming and all this unnecessary shit that's gonna complicate the thing that you're trying to accomplish. It can all be done by air. You just really have to know what you're doing. The other thing he didn't do is that these are the two exhaust ports, and for starters, he didn't use a muffler, which is going to make things dramatically quieter, but also for the retract of the air cylinders, we want to make it slower because as soon as somebody sits down on this chair, we don't want the cylinders to retract immediately, we want them to go slowly. So the first thing I've got here is the muffler, which is gonna go on the extend side of the cylinder. Get some fucking Teflon tape on this bitch. That way we don't get any more leakage. Ah, fuck. And by consulting the little pictogram on the valve here, I can tell that in its normally closed position, we are going to want to connect this to port R. What the hell does this R even stand for? Relieve or release, or I don't fucking know. I know P is pressure, but wait, R and what the fuck is S? Yeah, who gives a shit? I'm just gonna start with this. Now for the retract end of things, this is the side that we want to control the speed. So I've got here this flow control exhaust. And essentially the way it works is that this screw here controls how much air comes out of these holes here. And this lock nut here prevents the thing from unscrewing itself, because that is going to cause some problems if you have, say, an application where you need a slower extend or retract or whatever the hell you're doing. But in this case, it's so the air cylinder can retract very slowly, thus making it completely impossible for whoever's sitting on this chair to avoid being toppled out of it. At one point, I used to think that you can never use too much Teflon tape, but boy, was I fucking wrong. Ah, shit. All right, let me scrape this off. All right, that should do it. Now in you go. Before I forget, the other thing that Michael did wrong in his ejector chair is a bit of a rookie mistake. If you look closely at this still shot from his video, you can see that he's got 2 separate solenoid valves, one going to each air cylinder. Now, I'm not going to blame him. This was actually something I thought you had to do. That way you didn't lose any pressure. But what you can do, and in my case what I will do, is only use one valve for both air cylinders. The only reason why you would want to use more than one valve is if you're doing 2 different processes. But if you're using 2 cylinders that are doing the same thing, then you can easily use one valve to control both. You're not going to get any pressure loss in any way. So I've got both my mufflers on, so that way this thing isn't loud as fuck. And now I should probably get started with figuring out how the shit I'm gonna mount this thing. So here's the underside of my chair, and as you can see, I've already traced out where the valve has its own outline. And the reason I don't have it in the middle where this hole is already conveniently located is because this is not where the most weight is exerted on these chairs. If you know anything about human anatomy, which I don't, it doesn't take anybody with a PhD to figure out that the most weight exerted on these chairs are on the sides because of your butt cheeks. So that's exactly where I'm going to mount this thing. And I'm probably going to have it where this hole right here is drilled through this crossbar, and it should probably stay in place, but I don't fucking know. Oh shit. Well, that certainly wasn't as hard as I thought. Alright, so we've got our hole, and yeah, this thing fucking fits. But this thing isn't nearly long enough to reach through the padding, let alone this sheet of plywood that this thing is on. So I'm going to go ahead and use this aluminum spacer that I have here, and this is also the same diameter as the hole I just drilled. Ah, fuck. Well, I guess that shit ain't coming out anymore. So once I push this down, let's see how far it goes. If I go here and push it, oh. Alright, so yes, that is in fact going to work. So now for the tricky bit, I need to figure out how I can drill a hole so precisely that it will match up with this hole right here. So after fanning away my brain fart, I decided that I'm going to remove this ass pad and then drill a hole without this piece of wood inhibiting it. Now some of you or none of you or maybe a shit ton of you might be thinking, why the hell am I doing this when Michael already did it? My simple answer is that I work with pneumatics every single day, and while what Michael built was certainly effective, I want to teach you all a thing or two about just how much you can accomplish using air only. Alright, let's get this bugger out of the way. And now I should be able to work on this. Alright, so that took several tries and a shit ton of cursing as per usual, and I ended up having to kind of use my hand drill to mill out a channel because the precision hole just wasn't gonna happen. Anyway, that shouldn't matter. All that really matters is making sure that this thing gets inserted properly and bolted in place even more properly. So first let's put the ass pad back in place. Alright, spacer's pressed in. You can see it there. Now, valve goes in. Should be able to fit a 1/4-20 through here. No. Okay, looks like I'm going 12/24. And of course, no thanks to Murphy's fucking law, I was out of 12/24s. So, I went ahead and found this screw that's more than definitely long enough. And while it's not quite the caliber that I wanted it to be, it'll get the job done. This is fucking exciting. Should be able to tighten the hell out of this one. This is getting a little precarious. Alright, she's definitely on there, but I'm gonna keep going until I get a little bit of an indentation on this crossbar. Oh fuck, did the threads just strip? Alright, they might have stripped, but hopefully... Oh yeah, that's not fucking going anywhere. Alright, so that step is done. Now I think we can move forward. Now the other thing that Michael didn't do in his ejector chair is filter his air. And this is the biggest cardinal sin of all sins that could be considered cardinal. Filtering your air in the world of pneumatics is an absolute necessity. Not filtering your air is basically the same as driving your car with no oil in it. And I'm not saying driving your car with really bad oil in it, I'm talking no oil at all. It is completely running bone dry. And nobody in their right mind would ever do that, in the same respect that a pneumatic engineer wouldn't run any sort of line unless it's filtered. So we've got our QD fitting. QD, for those of you who don't know, stands for quick disconnect. And we've also got a threaded T and an elbow, but I'll get to why I put those on in just a second. Now, the place where I bought this from, they said that this bracket right here would fit this filter, but of course, because it's an online store, no, it fucking doesn't. So I'm gonna have to MacGyver this and see what I can do. All right, let's see if I can use these tie straps. All right, that'll get it halfway there. All right, I'm gonna want this sucker right about here. So let me drill this hole. All right, not too shabby as a start. And yes, I'm using these air cylinders to weigh this side down because I've got no fucking clamps at the moment. Deal with it. Now I've got one to put on this side to make sure everything's all equal. All right, so far what I've done is used 2 tie straps, one to bind this end down and one to bind this end down. And it seems to be holding pretty fucking steady. But it's getting late in the day, and I'll need to continue this all tomorrow. Day 2 of the ejector chair build. And, oh right, I still gotta fix this thing. First things first, I finally got some working lights up in here. So, that's a plus. Next, I'm going to need some air again, so let me go ahead and fire this up, and now fire the compressor up. So last time we left off with installing this filter along with the T and the elbow. And what I did off camera was I installed the pilot valve. This crossbar runs diagonally in relation to the structure of the legs. So I went ahead and decided to drill 2 holes and mount the pilot valve going that way. Of course, you can see it for yourself, so why the hell am I even explaining it? So the next step in this whole clusterfuck of equations is to install the air cylinders, which I've got right frickin' here. So here is one of the air cylinders I'm going to use. Obviously, because I'm not stupid, I bought 2 of them because, you know, 2 is better than 1. Now, anybody could figure out why this thing is called a round body cylinder. So I'm not going to waste my breath and explain. But if you can't figure out why this thing is called a round body cylinder, then we need to have a serious talk. The other thing that Michael did that I consider to be absolute overkill is that he used what's called a tie rod cylinder. Here's what a tie rod cylinder looks like. As you can see, it's got these 4 rods that are literally tying this thing together. And the advantage that this has is that you can take these apart and fix them, as opposed to this cylinder, which is non-repairable. Now, depending on the application, a non-repairable cylinder may be the best option because when the cylinder fails, which it eventually will, it would cost you more to try and repair the damn thing than it would be to just replace it. It's a classic case of the juice ain't worth the squeeze. Now, these tie rod cylinders are very commonly seen in much wider bores, meaning this tube right here, much bigger diameters. I'm talking like 4 inches, 6, 8, 10. I've even seen up to 14-inch bore. And when you're talking about those sorts of diameters, the cylinders alone are going to cost you at least $800 to $1,000. I've seen up to maybe $3,500 for a cylinder of that nature. But that's not where all these companies are making their money, believe it or not. They're making money hand over fist off the spare parts. I mean, yes, these tie rod cylinders alone are going to cost you, but they know that nobody is organized these days, and once they take these things apart, they're going to lose a part, or 2, or all of them. So once you realize you have actually screwed up and you need to call these folks up and get a replacement part, on the other end of the phone, they're thinking, yes, this is the sucker I want to talk to because I'm going to mark these spare parts up 300% and basically scam them out to make sure these are up and running once again. Anyway, who gives a shit about this thing? This is the star of the show right now. In fact, so is the other one. Of course, the last thing I have to say about Michael using this sort of cylinder on his ejector chair is that it was probably overkill to the nth degree. Like, I cannot even put it into numbers. These cylinders, and especially the exact one he was using, I have seen those exact cylinders used for hoisting up motors and crushing empty oil barrels. Yeah, I shit you not. Hydraulics aren't the only thing that help crush oil barrels. Pneumatics can do it as well, because hydraulics are expensive. Air-powered machinery will cost you significantly less than anything that's hydraulic. Anyway, get this fucker out of the way. So this cylinder is a 2-inch bore, which means if I have 100 PSI coursing through this sucker, this thing is going to dish out 200 pounds of force at a minimum. All right. Now, because these are going to be mounted rod side down, I don't want to have a whole lot of bending in the tube, so for this end, I'm going to be using some elbow fittings. And before I put the other fitting on, this is where I have to stress filtering your air. Because this cylinder is non-repairable and this rod has to be very, very clean, the last thing you want in your airline is dirt or grime or dust or any of this shit that is gonna clog up the cylinder and contaminate it. I recently had to take out a cylinder much like this one, and the rod was completely rusted over. And why? Because whoever installed that airline had a filter, but they never changed it. Anyway, enough of my blowing off some steam. Let me get on with this one. Now, I almost never use these sorts of tube fittings with the plastic bits on the end. I always use all metal fittings, and that's because if you're tightening these down and your wrench slips, guess what? Oh shit, I'm going to crack this thing, and now I have to buy another fitting. The metal ones you never have to worry about. You probably just like nick them a little bit, but that's all that's gonna happen. Now, because these rods don't cover a decent surface area for the ground contact, I'm gonna be adding some of these. Actually, let me make this a little easier to see. Nah, still not good enough. There we go. All right, the thread pitch of this rod end is 1/2 so as far as I know, that's what the thread pitch of this is. Yep. And I'm going to go ahead and thread this sucker on. This way we have better ground contact whenever we fling our victim out of the chair. All right, that should do it. Now this end is gonna be closer to the valve, so I'm not worried about any bending. We're just gonna use some straight up, shit, this isn't it. Some straight up fittings that are not elbows. Now to me, these ones don't matter as much as to whether the end effector of it is plastic or metal. Metal is just my preference because where I work, a lot of corrosive chemicals are used, and I don't like it when things get dissolved. Alright, that looks pretty fucking happy. Let's move on, shall we? Picked up some hose clamps this morning to help keep these suckers on each leg, and that doesn't need any further explanation, so let me just go ahead and mount these. Alright, that should do it for the cylinders. And now, the tubing. Now, of course, I'm a bit of a doofus, and I forgot to add some extra straight fittings to my order, but nonetheless, I found these grimy, janky-looking fittings, but they'll do the job. Now, of course, this is the opposite of what I like. This is an all-plastic fitting, which means if one of these breaks off, I am fucked because now some of the threads are stuck inside. And I've used pipe extracting tools before, and they are not fun, especially if it's something plastic, because once it finally gives way, I'm probably going to mar the internal threads of this valve, for example. All right, let's see how much of this tubing I really need. Now this here is the solution to Michael Reeves' issue of using 2 solenoid valves, 1 for each cylinder. Instead, you could just use a simple Y fitting to use 1 valve for both cylinders. Yeah, this is too long. Gotta cut it shorter. And that does it for the retract side of things. And now for the extend. Now, to make this thing a little bit more not so obvious. All right, now we have to take the input side of our valve and connect it to our filtered connector. Now, before you comment on how I'm fucking this up and not using the wrench the proper way, let me see you try to wrench this thing into place while there's 2 fucking mufflers on either side. And now to make the return tubes a bit more not so obvious. Now that that's done, I now have to supply air to the valve that's bolted to the ass pad. And just like that, we are done. So there you have it, 1 fully pneumatic ejector chair and not a single trace of electronics whatsoever. Now, of course, before I continue, I need to hook this fucker up to some air and dial in the appropriate settings for the retract speed. All right, now let's see how she fires away. All right, well, not too shabby. It'll certainly knock you over, but certainly not at the speed that I was anticipating. But hey, I can't complain. I want to slow the retract down a little more. Let me loosen this and tighten this. All right, now let's see how we do this time. Okay, that is a bit too slow. Let me open this up a little. All right, 3rd fucking time's the charm. All right, looks like we have a winner. Now to actually test this thing while it's on its feet. The maiden voyage of the pneumatic ejector chair. Not exactly sure how things are gonna end up, but here goes nothing. Whoa! Holy fucking shit, that hurt. I love it! So there you have it, folks. A fully pneumatic ejector chair. Inspired by Michael Reeves, but perfected by me. The moral of the story here is that you don't necessarily need electronics to do what you want to do. All you need, really, is some air and a little bit of know-how as to how you want the air to work for you.